It's the he asked what exactly is salinity. It's basically the measure of salt that's in the water. That's the general term for it. But yeah. Anything else? No. Okay.
PAR, or photosynthetically active radiation, which is basically just a fancy word for sunlight, affect growth rates in phytoplankton. And the reason I wanted to do this was because there are two really big groups of plankton, zooplankton and phytoplankton. And phytoplankton are the little algae in the water that do so many crazy good things for us. And I hypothesized that phytoplankton exposed to higher amounts of natural sunlight, but not extreme levels, will grow at a faster rate. So there are plenty of reasons why we should care, but not everyone really thinks about plankton 24/7 as some of the people here do. And the thing is, phytoplankton are insanely important, and it's not something that everyone knows. They're the base of the food chain as primary producers, and they play a huge role in the carbon cycle, pumping out billions of tons every year. And cyanobacteria, which is one of the types that I used for my experiment, is one of the oldest strands of plankton. There are many fossil records of them. They date back the farthest, and they played a vital role in evolution. But not everything is so bright and dandy in the phytoplankton world. We can thank them for harmful algal blooms, so red tide and stuff like that. Both of my specimens cause that in different areas. The one in particular has only recently been discovered, and it was in the Fonry Bay in 2002. One of its blooms knocked out 90% of both the plant and animal species in an area. So it's really intense sometimes. So they are really amazing, and they're really terrible at the same time, and I love it, and I wanted to know more. So what did I do? I sat inside all day, and I counted slides of plankton. That is what I did. And so 6 samples of plankton are set outside in the sun for a full day, a 24-hour period. Samples were taken before and after and analyzed. And this is actually the computer that I use. I had a microscope set up to a computer, and I went through and took pictures systematically through the slides and scanned them for plankton. And the way that I measured how much sunlight they were exposed to, I put layers of wiring around them. There was one with no layers, one with 1 layer, and one with 2 layers. And the layers individually would block out approximately 50% of sunlight. So what we assumed was that the bottles with 1 layer of wrapping had 50% exposure, and the bottles with 2 layers had 25% exposure to sunlight. And you can see the ones that I used, they're pretty colorful, which was kind of cool. They were dyed. The 2 in the middle are the ones I used, the pink one and the orange one. So for my baseline samples, I found 883 plankton. And for the second one, I found 1,940 plankton. And then, so you can see kind of what I was looking at. We'd have some slides where you'd have a ton of samples, and then some slides where maybe you would have 3. So it was really interesting to watch the fluctuation of plankton throughout the slides. And then the really cool thing about the second species was that they would form clusters, which are both beneficial and detrimental to them, because